afternoon's very full of schnitzel and potatoes, so I'm going to try and wake you up by saying some provocative stuff. I'm assuming you're not here for the wishy-washy stuff, the safe stuff, so I'll try and be a little bold. You can come argue with me about it afterwards, okay? I'm going to talk about the intelligent wave and how a growth of intelligence across the board, okay, AI, but also in advanced processors, is going to change the industry and drive RISC-V. I am the senior principal analyst for IoT at Omdia for 3 more days. I'm going to tease you about my next job for the 3 of you who are invested in my career that are here, but it will actually apply to people in this room. I'm staying with Informa, but I'm going to have a slightly new focus, a very exciting one, and I'll talk to you about that at the end. So pay attention. It's a little treat for you. This is what inevitability looks like. This comes from our recent report on the RISC-V Market Tracker. Okay, this looks at processor counts. It started last year just looking at IoT. Now we've also looked at the mobile space and the enterprise space. So once largely thought of as deeply embedded, and I still get that. I had someone arguing with me on LinkedIn the other day. We ran a press release about this report, and they corrected me about RISC-V. They said RISC-V is for microcontrollers and deeply embedded sensors. I'm just going to give them Jim Keller's email address, so you two sort it out. Omdia expects RISC-V to have more than 1/4 of IoT processors in 2030. Now that is just a massive leap. Okay? IoT in particular is where we think the growth is going to begin, but it's going to accelerate everywhere. There's a lot of assumptions made about IoT hardware, and they're the same assumptions that get made about RISC-V, that it is about microcontrollers, that it's about sensors, that it's about basic stuff. And I think both of those assumptions are incorrect and misleading. This is the total processor volume by application that we see. Right? So we see things growing pretty nicely. Industrial's going to still have the lion's share of that. 30% industrial devices in 2024, 80% CAGR in IoT from 2020 to 2025. That's a lot of growth. I mean, IoT is, I've complained about this before, it is a terrible term. It's not on the internet, it doesn't connect things. It is embedded connected devices. I think there we see it is where a lot of interesting things are happening, and interesting things will continue to happen. And as the growth of AI comes across, we're going to see a lot more things moving. Why do we count processors? If you look at the reports on RISC-V, they're all a little bit different. It's difficult to find a useful metric that can compare things evenly, because if you count main core chips, then it looks like ARM has this insurmountable advantage. And if you just count cores, you get things like these massive Esperanto, things that have 1,000+ cores. We count processors because it's the best proxy we have to show how designs are shifting. Okay? One interesting thing we're seeing is that the amount of processors per chip is increasing, and I think that is going to help RISC-V. And I think that's worth looking at when we think about our future. Applications processors are what are driving IoT value. We looked at in 2020, it was about 21% of the IoT value, 25% in 2023, and we are looking at 40% by 2030. Now, what is happening here? We are not just seeing applications processors getting more complex, and we're seeing new processors added, we're seeing multi-core. I'll talk about that a bit more in a sec. We're also seeing applications processors in places that used to be microcontrollers. We're seeing things move from the basic MCU space to the more advanced MCU space, and we're seeing that in the sort of the crossovers that we're seeing a lot more of. We think of things in sort of terms of this inside Omdia, inside my group, and these quadrants. Okay? And you can think basically as above the half is Linux capable, left-hand side maximizes power efficiency, right-hand side maximizes performance. And we are seeing a general shift from bottom left growing up and to the right. And that's across the board. And that's sort of documentable. Everywhere you look, you will find this shift happening. And this bottom left is getting filled in. Okay, every time you add an applications processor, you need more sensors. You need to collect more data. But it's getting filled in interesting ways. And I think that we're going to see a lot of energy harvesting and a lot of sort of really long-term battery life sensors. And then you can begin building things into stuff. That gets really interesting. These are sort of 3 examples that I use to demonstrate how uniform this shift is and how predictable this shift is. So all these devices in 2016 all had single-core ARM v7 as their CPU. And all of them in 2022 and beyond have quad-core ARM v8 with a GPU, with supplementary IT. Okay? And the device themselves barely changed. You look at Echo 1, you look at Echo v3, and it's more or less identical. You look at the Chromecast, hasn't changed much. That Advantech IIoT gateway isn't doing something substantially different in 2022 than it did in 2016. But the ecosystem, the environment, the software, the processing that it's doing under the cover has advanced so much, and it's got that hardware behind it. So I've introduced what I call the squashed rhombus of the IoT. Okay? We are seeing this convergence here, where the advanced performance stuff keeps shooting up. We'll get V9 in there, we'll get the advanced 64-bit RISC-V stuff in there. The CPU will keep getting bigger, and that tree is going to keep growing taller. At the same time, the standard performance MPU and the higher performance wireless MCU are converging. If you have a really high-end multi-processor microcontroller SoC, you've got something like, there's some ST chips that I can think of that fit into this space. We've got an M4 and an M0 and maybe a security MCU. That has much more in common with an entry-level MPU than it does with something, a 16-bit or 32-bit, at the far end that's not doing very much. That's collecting a binary sensor data or just managing a simple connection. So we see that convergence. The differentiation will be based on the level of compute. This is an interesting question I like to ask. What CPU do you use when the CPU is the least interesting part of your chip? What do you use when you've got a GPU to manage, you've got some acceleration in there of some kind, you've got some security that's extremely important, and you've got a CPU for just doing some basic maintenance, some basic admin. Okay? I think there's a huge opportunity there for something that is cheap, safe, and cold, where you've got that efficiency, where you're not spending too much on your licensing, and you're not dictated to the whims of whatever ARM's decision is this week on how they're licensing their cores. It is an interesting thing to consider when you're planning your designs. More general purpose is more entrenched, and I think I'm going to say some stuff that's not super controversial, but still needs to be said. Where is the moat? Okay? I've argued elsewhere. I gave a talk at Applied Intelligence Live last year called The Lesser Moat that argues that basically the MCU space is harder for RISC-V to crack than the MPU space will be. Okay? MCU has a higher rate of general purpose, and when you have general purpose, your redesigns are more consistent, and you stay with the same ecosystem. MPU is more of a software proposition. If a box runs a given set of software, then you are looking at the given set of software that it runs. You are not that concerned with the box. As long as it runs Android, as long as it runs your Linux, that is your main concern. Whether or not it is ARM v7 or v8, whether or not it's RISC-V or not, doesn't really matter. It doesn't really matter if it's x86 for them to some extent. Your other considerations on that will be what you buy it on, whether or not it's expensive, whether it's long-term supported, whether or not it's economical to run. The box doesn't care. And I say this a lot. The box doesn't care where it is, what it's doing, or what's inside of it. What the box cares about is its software package. That's all it wants to do is run its software package. And we get a bit inside baseball-y sometime about this, about whether or not it's RISC-V or whether or not it's ARM or x86. If you're designing, you start out with what is optimal for this situation. You are concerned about the situation, not what's underlying it. Maximizing your software interoperability is crucial, and that's why I think RISE is such an important initiative, and why I don't want to give him a big head, but why I think RISC-V International is doing a fantastic job of managing that collaboration and keeping that collaborative effort and ethos going. When I speak to people about RISC-V who don't know much about it, to be honest, they're always amazed when I tell them about the collaboration and how well the cats are herded and are willing to be herded and keep running together towards the same goal. It's really genuinely impressive. No chip-for-chip replacement. We talk about that a lot, but when I say that, we say that you're not going to tear up a design that's running and redesign it. But redesigns happen, and when they happen, they're usually spectacular. And I think those redesigns don't come up that often. When they do, there's always that opportunity in there. It's not going to, if you have an STM32 that you're shipping right now in bulk, you're not going to say, well, let's stop doing that and redesign it for RISC-V. If you're using an i.MX, you're going to say, well, we can do this on RISC-V now, so let's do it for the novelty. But when that device ends its life cycle, for whatever reason, because you need to add AI, because there is a new security initiative that needs you to have it, comply with Cybersecurity Initiative 2.5, then that redesign is obviously opens things up. Secondary cores, parallel processing and accelerated processing of any kind, custom processors, I mean, anything like that is an opportunity. And there are going to be a lot more of these opportunities as things like AI, as things like more advanced compute lift the market. Novel applications will be a ladder, okay? AI is a novel application, and AI is certainly permeating the society, but I want to take a slightly closer look at how the AI market is driving things and what the AI market is doing right and doing wrong. Have you ever heard this before? This is, if you listen to any talk, you will hear about this. And I think it is really useful to replace AI with software when you hear people speak about this stuff. We're increasing our software budget by 50% in the hopes that our software will be bigger for next year. And what if we increase the software by 100%? We'll be able to do twice as much software in the future. What can't this software do? There are limits of gigantic AI. And I say this not because I'm against big AI, big Gen AI, but because I'm evangelical about embedded AI. Okay? AI that solves problems is what to invest in. When I speak to people's startups, when I talk to people who are getting into startup programs, I always say, solve a small problem perfectly. And that is, I think, the only way to approach AI, is to say, what does this fix? Does the power and the engineering time that we put into this improve the output to an extent that it's worth our investment, that it's worth the copper wire, that it's worth the sackfuls of coal that are taking to get this AI product out? Okay. Our AI survey showed that 50% of companies we surveyed, and these are large enterprises, have not just an AI budget, but a Gen AI budget. They are spending specifically on Gen AI. Okay. We are 2 years in now, and there are going to be some hard questions in these boardrooms about what return they are getting for spending on Gen AI. They've got some chatbots. Right? Gen AI does some amazingly cool things, but where it is interesting is where it is deployed on the edge in embedded situations. Right? There's concern that we also hear from these surveys about things like confabulation. The Air Canada case is going to haunt a lot of people, where the AI made a promise that the company did not much want to keep. Limited improvements and required supervision. So the more money we spend, we're not getting the same returns. Right? And it still needs someone to go in and double check, but the AI does a lot. It needs these human overseers. And continued investment in that is going to be difficult. That money is going to be redeployed, if we're lucky. It not just gets swallowed back up into general funds. When it is redeployed, it's worth pushing for that to be deployed on the edge. We get solving specific problems, using that and saying, what is it we want to figure out? What is this? We want to spend this money on this piece of software that will solve problem X by making it more efficient, by increasing our options, by giving us more flexibility. That is the way to address this sort of Gen AI, embedded AI distinction. Talk about the problem you're solving. AI without the ATP. Okay? ATP is an in-house term that we use. It stands for and then presumably. Okay? When you hear someone say and then presumably, that means the next thing is something they don't want to do because it's too expensive or difficult. Right? So we used to talk about this in IoT all the time. People would be shoveling mounds of data up into the cloud, and then they'd wave their hands and go, and then presumably, this will be sorted and insights will be generated from it. Those insights will be acted on, and we will get a result from it. That's ATP is happening right now with a lot of the Gen AI stuff. We can do these amazing cool things, and then presumably it will translate into action somewhere down the line. AI that happens closer to the data edge, okay? And this gives us a scope for things like closed models, okay? If you have an LLM that can run locally on your device and focus on a specific sandbox data that you have control over, then you have to worry less about confabulation. Then you have to worry less about glue in your pizza sauce, okay? That you have more control over the data, you can make it less messy, then you have much more control over your output and much more useful output. Minimal transmission. We also speak airily, and this is my ATP, about things being in the cloud or on the edge, and it is never that simple. Okay, your device is on the edge, you've still got to update that device. You've still got to maintain that device. That model is going to need checking and refreshing, and you're going to have to spend the money to do that. And transmission is expensive. Connectivity is expensive. Processing is cheap. Okay? So the more that we can get these devices to run minimally on the edge and call home as little as possible, the lower your power budget and your data budget will be. And that's going to be an important consideration. Okay? So this is the big slide. Okay? RISC-V processors in AI applications, the thing that LinkedIn commenter told me isn't going to happen. Okay. Accelerate for a purpose. Again, look at what you're doing, and it's why seeing it growing in things like industrial, automotive. Okay, those are spaces where that AI has to be lean, where it has to actually have a purpose. Industrial isn't going to put AI on chips. It's resisted it so far. It's gone through 3 waves of AI where we said, well, it's definitely going to happen. We can do digital twin. We can do predictive maintenance. We can do all this cool stuff. And industrial said, we cannot use it yet. Now is the time. Now the AI is strong enough, robust enough. It's been years of TinyML demonstrations that work amazingly at Embedded World with their little Lego set, and you press a button and the motor goes from in tune to out of tune. The real world is messier than that, and industrial is aware of that. They know that things matter depending on what part of the factory they are, whether it's afternoon or morning, whether or not the material has been old or new, whether the material is wet or dry. All these things matter, and you need a robust AI to fix that. And now we're at the verge of having that, and I think it's really worth sort of seeing how industrial and automotive together are going to help lift this. Flexible, scalable processors, and I think that will, sound like any ISA that we're here to discuss. I think there's a huge opportunity here for this. Customization cuts power needs. Again, people are paying their own bills for stuff on the edge, and you can't just build a nuclear power center the way they speak about doing for these data centers, just to run stuff on the edge. So we're going to have to find a way to keep energy bills not being an obstacle, not being a way for the board to say no to a project. This time for sure. Okay. Trends towards ASICs and ASSPs away from GPUs. So this is from my colleague Alex Harrowell's AI report. But this just shows where we're looking at the actual hardware deployed on the edge. And you can see those GPUs, right? It's actually fairly steady compared to the way that the proprietary core ASSPs and ASICs are growing, non-GPU ASICs. So I think that says a lot, again, about the kind of efficiency. You don't want to cook breakfast on your AI processor on the edge. You want to be able to have that run cool, run efficiently, okay, and run in a focused manner. RISC-V processors are predicted to make about 10% of these edge processors in 2030. I think that's pretty good. And if you exclude GPUs, and I know RISC-V can do GPU, but I'm saying if we just look at the stuff that is in the ASIC and ASSP space, that's 15%. And I think that's, that is a pretty good return. The tail behind these processors is also huge and important. Okay, so if you're adding AI to a chip, what else do you need? Are you also adding security? You have a CPU to manage it. Are you having secondary controllers on there? Is there connectivity that needs to be added to it? And can RISC-V fulfill that? I think it's worth saying every time you see an AI chip deployed, an AI processor deployed, how many other processors do you need to support it? And where is RISC-V a natural fit? Or you could develop a product that's a natural fit for it. RISC-V and advanced edge processing, okay, are going together. And you can accelerate things other than AI, but I think acceleration in general, advanced intelligence, okay, is going to continue to buoy this industry and to push products and give you new opportunities for new devices. Okay. The more compute, the more supplemental IP. Okay, the more you are doing processing, the more that processing is dealing with smaller components, the more opportunities there are. Okay, you can't just throw a 64-bit multi-core processor out into the world and say, you're on your own. You need to have the security, you need to have the controllers, you need to have probably GPUs and AI attached to it. Each shift is an opportunity. So every time you see the market move, up one rung of that ladder, of that squash dramas I showed you earlier, each time a chip moves up, that is a redesign. Every redesign is a chance to get your IP in there. The largest and most influential shift in the embedded space. So we have seen how AI has transformed, well, the evening news, and the way it's transformed the data center. And now we're going to see AI affect the embedded space. And I hope that we do it with a bit less hyperbole and a bit more focus on what we can actually get out of it. It's going to do things, okay? And that, I think, is the coolest thing to talk about, where AI is a feature, not a product. We are not selling AI for the sake of AI. We are selling AI because it can solve X. Right? And that is why I'm interested. I'm going to give you a hard sell for a couple of minutes. So I am part of Omdia. Omdia is part of Informa. Informa owns just a whole bunch of stuff. So we own all these publications and events up there. We own Black Hat. We own Ward's Automotive. We own Data Center World. And we own London Tech Week. Okay? Omdia is the research house that brings together all of these divisions into one group. So we are part of the former AHS Market, Ovum, Tractica. We're all brought together along with now Canalys we have in our house. So we offer 250 analysts in sort of 12 divisions focusing on more or less anything technology you can come to. Which leads to my role. I will be heading up our automotive group starting the end of this week. So I'll be Senior Research Director for Automotive. My work will still be supported inside the IoT group, so if you're interested in our RISC-V Processors report, RISC-V Market Tracker, it's on sale this week, in fact. So come talk to me about a one-off sale on that. We'll get you a good deal. You can have access to a lot of data and some analyst time on it. And then in the future, if you're interested in talking to me about automotive, so we have Ward's Automotive, Ward's Intelligence, and I'm going to be doing a lot in that space to bring promotion of RISC-V, but also generally how technology can be incorporated, how semiconductors and GPUs can be incorporated into the automotive world. So I'm really keen to talk to people in the automotive space in RISC-V, so please come talk to me about that. And I think that's basically it. So thank you, everyone. Appreciate your time. Okay.
So we do have a couple of minutes here, so if anybody had a question, happy to take that. Well, I'm not happy to take it, but Edward's happy to take it. Any questions that we have here? Yes. Yeah, please. The microphone is coming from behind. Other shoulder.
Hi. We actually talked a couple of weeks ago. My name is Pablo Valerio. I work for E-Times. And I wanted to, you mentioned a lot of different figures here. And one of the things that you're saying is you count processors, you're not counting cores and things like that. Do you have any information more about how it's spread basically the development and the, let's say, the product is across different regions that you can share?
Yes, that's what I can tell you is that about 50% of it is expected to be in China, is currently in China. And I think I expect that might actually grow. So I say 50% of RISC-V processors are currently deployed in China. That's what our work has shown.
In any particular, let's say, for industry, or is just across the board? Or?
In mostly industrial. And then I expect it to gain more of a foothold in automotive, because the transformation in the Chinese automotive industry from sort of analog to fully digital is breathtaking. And there is very much an awareness that governmental interference could take away their access to a lot of other popular instruction set architectures at any time. And there is strong government incentive to work with using RISC-V. So I expect that to put, that's an excellent question. Thank you for bringing that up. I expect that to really push the automotive shipments, in particular, automotive and industrial shipments, where there is an interest in self-sufficiency. So you could actually begin to see, RISC-V-based semiconductor manufacturing devices, which I think would be an amazing, development. But yes, it's like 50% in China alone, not just Asia Pacific, 50% in China.
So it sounds like with your switch to automotive, next year you're going to be saying automotive is driving RISC-V. Is that? Yeah.
No, I don't chase the glory. Don't worry. I don't.
Okay. Other questions? Any other questions? So I had one question myself. You were saying that MCUs are maybe not where RISC-V is actually going to make a dent going forward. But what about? So what are you considering as an MCU? Is it the actual device, and what about sort of the helper cores that are sitting around the
That's another excellent question. I think that is more interesting for RISC-V than the sort of non-Linux capable processors, the MCU type, microcontroller type processors. I think security is a huge area because there's a lot of new applications that need to be secure, or made secure to a specific standard. And I think we'll see more government regulation in that space, rather than less. I think more specific regulation, and that is going to be a huge opportunity. Again, for a whole redesign of the whole chip, it's very unlikely that you can just bolt a little fix onto things. That it's easier to start with tape out on a new design in that case.
So similar to the way AI is a new area that RISC-V can expand into. Security.
Security is absolutely
could be on the lower end sort of thing.
Definitely.
Okay. Okay. Very good. So thank you very much, Edward.